Hi, my name is Christopher Johnson. I want to tell you about the project Elena Burns and I have been working on and show you some of the progress we have made. The name of our project is Non-Static Biometric Identification. We are attempting to create a device to capture a non-static biometric identifier for the purposes of authentication. Here's an image of the early stages of assembly. The innovative component of this project is the use of light patterns at varied intensities applied to the fingertip in order to produce an image. The resulting image is a non-static biometric identifier. Each pass through the scanner produces a unique image because of the random intensities and patterns of light. Traditional physiological biometrics compare a static image to a static template in order to compare for match. This makes them more susceptible to spoofing. Spoof resistance is one of the benefits of our non-static biometric identifier. For this sprint, our objective was to produce a prototype capable of capturing a non-static biometric identification image. To create the prototype, we are using an Arduino microprocessor controller, high-intensity LED light matrix, a TTL JPEG camera board, IR proximity sensor, various IC drivers and registers, a small project box, and a PC to receive and process image data. We are still missing some components this week, but the majority of them have arrived. We have provided some images of the early breadboard work and screenshots of the code. We made a lot of progress this week in the area of coding. Serial communications between the microprocessor, controller, and the PC are working. Currently, we're using a webcam to test the capture logic because the LED camera board circuit is not yet complete. The LED light array that is used to produce the random light intensity patterns has partial bits of code completed for its function as well, but have not been tied into the main beta program. The IR proximity sensor that will be used to detect that a finger is present in the scanner has yet to arrive. Attempts at designing a custom IR sensor failed. The IR sensor will also be used to trigger the processing code on the PC. The PC will perform various functions such as making image comparisons and feeding data back to the Arduino. The current method of image analysis is working on a pixel by pixel comparison that yields a percentage of pixel match. We may also use an offline comparison method to evaluate the accuracy of the device until we can produce a more efficient automated method. As we had discussed previously, there are other concepts we would like to incorporate as the project progresses, such as an input touchscreen and a device to communicate numeric codes to the end user through vibrations and the sense of touch. This system could in theory be used as an auto-enrollment method. Another conceptual idea that is being considered is a proximity network disconnect feature. This will require the authorized user to be physically present at the terminal. If a certain proximity parameter is reached, the device will tell the system to disconnect and end the session. This concept is intended for situations that require very high levels of security. To close the presentation, here's a look at the current project using the 6 thinking hats method. White hat. We have defined the hardware and code needed along with their function. We have partially written the code. We have partially wired the circuits. We need to define, learn, and implement the remaining unknowns. Red hat. We feel much better about the short-term goals. The coding is going much better than expected. We think this system will work. Black hat. Integrating these circuits into a small form factor may be impossible with our limited resources. Template matching code is still elusive and current methods may not be adequate. Time constraints make it more difficult to complete all the objectives in the project. Yellow hat. We have defined a truly innovative concept. We are making these ideas happen and moving forward with tangible results. The ideas behind the project have the potential to be expanded upon in the future. Green hat. Working on this project has produced a number of ideas and concepts that can stand on their own. We have successfully narrowed the scope to match all the current restraints. Failures have yielded great improvements programmatically as well as completely new concepts. Blue hat. We must focus on finishing the physical prototype. We need to define set limits for pass-fail and comparison algorithms. At some point, it must be decided upon whether to focus in on the non-static area of the project or to expand the project. A testing procedure needs to be established. Thank you.